Hi everyone, welcome to Life Edge, because life just doesn't have to be mediocre. I am joined today by my good friend and co-host, Dr. Susan Nash. Hi Susan, how are you?
Hello, I'm glad to be here, and I'm glad that we're doing something kind of different. Today we're going to be talking about machine learning, but just not talking about it. We have Alec Walker who's going to talk about and show us how to do it not just with Python, but with Excel.
Interesting, that would be cool. This is his third visit, so we're getting to know Alec. Here we go. This show is sponsored by Relate Corporation at www.relate.com, your training and video partner.
Hello, I'm Peter Baker. Please visit voiceovermasterclass.com to see details of the training courses I have on offer for new and existing voice talents to further their career by enhancing voice and technical skills, as well as essential marketing tips.
And we are back, and in that center position of power, we've got Alec Walker. How you doing, Alec?
Hey, I'm great. Thanks for having me back again.
Oh, our pleasure. I missed you on the second one. I was on your first show, but I missed the second one, so I'm glad I could make this one.
Yeah, for sure. Yeah, it's always fun chatting with you. We did our sound check 15 minutes ago, and that time flew by just hearing stories about your life and your work.
Yeah, I talked a lot. Sorry.
That's okay. When we're on these shows, you let me talk a lot, so it's only fair.
Fun.
Yeah, we got to do one where we switch and we do an episode about you and your experiences.
Oh, that might scare people. I don't know, but we could have fun with that. And Susan, what a day, huh?
Oh, yes. As they say, things will never be the same, but there are some interesting opportunities for us to all come together and learn more about how things are done. And that's why I'm so excited about what Alec is doing. AAPG is having a workshop, and we want to equip people with the ability to build their skills. And in this case, it's in machine learning, and in the tool Random Forest, which is used a lot in basically assessing risk and simulations, creating scenarios. And usually to be able to work in it, you have to program in Python. And that's kind of an impediment, which Alec will talk about. And so what we're doing is something that a lot of people can just jump right into because their data comes in Excel. And so instead of having to go through a number of steps. So AAPG is really excited to be able to offer this course, and we're offering it so that it will be simultaneously live, online, and face-to-face. So Alec, would you like to tell us something about, well, basically, why random forest algorithm, and what is it first?
Sure. So the decision about why random forest is that it's rapidly becoming one of the most popular algorithms for machine learning out there. So there's typically machine learning, there's two ways to think about what it does. There's classification, where you're trying to take a lot of different samples and decide which category they fall into. Maybe it's something like, is this a high risk, a medium risk, or a low risk situation? Or is this non-productive time, or is this productive time? Something like that. And then there's also regression, where you're trying to predict some number that's affiliated with a sample that you don't know yet. All you have is the sample. And random forest is good for both of those. So you learn one technique and you can apply it to both kinds of problems that machine learning typically tackles. Another thing that's good about random forest is that its biggest downside, let's see, how old was it now? 1995, so 25 years old. It's at the time that it was first proposed and that people first started to implement it, it's so computationally intensive that was a big weakness. And sure, this sounds good and the theory is nice and sound, but implementing on an ordinary laptop, somebody's ordinary computer, would just take so long. And now that people have more data, which it tends to be good at processing, and now that people's average laptops are just so powerful, it's become quite a great technique. In fact, there are some Kaggle competitions that if you just use an untrained or untweaked machine learning algorithm and you train it on the sample data in one of those Kaggle competitions, and you just like submit without doing any tweaking at all, you can wind up in the top 20 percentile of that Kaggle competition, and those might be less than 10 years old. So it's really made like quite a big difference in the machine learning community.
That's really interesting. So when you talked about classification, I don't know if you saw the Silicon Valley, the episode in the series where they are working on a classification machine learning app, and so it was like hot dog or not hot dog, so it could recognize foods. It's like hot dog or not hot dog.
Yeah, it's always like arbitrary. That's another thing that kind of like you have to suffer through when you're first learning about machine learning. Typically, is the use cases are just so random and far flung. Like the one that I first learned was like, is this picture, does it have a cat in it or not? And it's kind of fun to think about, like how would you train a computer to recognize whether there's a cat in a picture or not? But it's not very practical. So you spend like a month or however long it is learning all about how to do that, and you're kind of sick of like cat or not cat, and you want to like put this thing to use and add value in the workplace or something. Yeah, so that's something we're trying to avoid as much as we can when we teach this class.
Isn't the hardest thing about the machine learning really the pattern matching so that it makes sense?
Yeah, I think so. So machine learning is all about finding patterns, and then matching a pattern that you've already found might seem simpler unless what you think is a pattern isn't, and it's just overfit or it's just some random noise. So yeah, I think that's definitely the hardest
just
part.
Out of curiosity, I studied a little bit of machine learning back 70s. It's been a long time, and that was learning. I think I learned a couple of languages. Forth was kind of an AI language. You had Forth, Lisp, LISP. Those are the ones I learned back when, a long time ago. And I never really pursued it because back in those days you couldn't do much with it. It was just, it was cool, but couldn't do a heck of a lot.
Neural networks?
You could do a simple neural network, yeah, but it was ahead of its time. There just wasn't that much, and like Alex said, computational power, it just didn't exist. So whatever you did took, in those days, compiling like a COBOL program took 12 hours, maybe 1,000-line program, 12 hours. Think about that. Now you can do it in about 1 second. It's amazing. That's a big difference, 12 hours to 1 second, and 40 years later, that's quite an improvement. But interestingly enough, it was back then. It was creating. They didn't have much in the terms of patterns. At least visual patterns didn't really exist that much then, because there just was. We didn't even have what they call blobs in those days, binary large objects. There was few databases that could even handle that. So you had to represent things in a different way, and that means you were very limited. Now you're representing things with data. So the data you're getting, I noticed you're doing it in Excel, among other things. So are we talking numeric data for the most part, or other kinds of data?
Yeah, there's both. So really to back up, like last time that I've been on this show, the last couple of times I've been talking about Delfin, which is my company, and where we tend to help companies is on like a team level, or a P&L level, or a company-wide level. And they're dealing with data that is unstructured, and they're trying to structure it so that they can pursue their own machine learning or their own data analysis initiatives. And sometimes they partner with companies when they do that. Sometimes they buy an off-the-shelf solution. Sometimes they build things internally. But they have all this unstructured data. And machine learning tends to do well when you're trying to find some kind of a pattern once you've already structured your data, so you know what each sample means. So we help set that up for those kind of people, for team P&L or company-wide problems. But there's a bunch of individuals in the companies that we deal with who have developed their own workflows and their own, I use the word siloed cautiously here. It's not like they're trying to hide their data from their team. They have their own data that they use to get their work done, and they've developed a workflow that works for them, and that's been good enough for a while. And that data is sometimes it's well organized and sometimes it isn't. And so rather than use Delfin to try to help people on an individual level, I think it's become more practical on that level to just empower the individuals to help themselves, because it would cost too much for each person to use Delfin in that way. Delfin's better on like a team level.
Yes, and that leads me to what I think is really, really revolutionary about this kind of training, is that when they walk away from the course, they don't just have a subscription to somebody's app. They actually have their own tool that they can start using. And I don't know if you brought a case or an example of it, but
sure. Yeah,
I
have something I can demo here. I can show the tool to everybody. It's it's a tool that I think is useful, but inevitably I think what'll happen is people will first, they'll be motivated by the things that you said when we started the show. When I was an undergrad, I was a chemical engineer, and our professor said, "Hey, this is really tough, but your reward is industry. Once you learn all this stuff, you don't have to learn anymore forever. You just go to work and you implement what you learn." I don't know if that was ever true, but it certainly is less true now, right? You have to, in order to keep the job that you have or get the job that you want in the oil industry, you have to demonstrate that you can continuously optimize your workflow. You have to, either through step changes or gradual improvements, create more and more efficiency. And so I think it's inevitable that people will start to use the tools that are more cutting edge that other industries have embraced already to do that, like R or SQL or Python and that sort of thing. But if you don't know about those tools, it's kind of intimidating to learn about machine learning and R, or machine learning and Python at the same time. It's like going to college in a language that you don't speak, in a country you don't know. You gotta learn the language, then go study somewhere abroad, or something like that. So I want to preface my demo here. Like, definitely the tool that you would come away with if you take this class is useful, and you can put it to use right away on your work. It's not, Excel is definitely not the right language to build machine learning for like the most optimal kinds of process, but that's okay. You can learn how it works and you can implement in a way that adds value, and because then you understand how it works, I think inevitably you'll start to use these other languages and companies will start to support that. So this is kind of like a stepping stone, not like a perfect patch that solves everything. But yeah, it's still a useful tool. So you get to keep it and also know how it works. Yeah. So should I show you guys right now? I'm eager to do it.
Yeah.
I'm going to share my screen. Let me know when it comes up.
While we're waiting for it, I just wanted to say that we're really appreciative, because so many times training doesn't empower, it just makes people dependent. And this is a way to empower.
It just came up.
Yay.
Oh, cool. Yeah, so what we're looking at here is these are a bunch of wells, and kind of like change things around a lot. So the location name is changed, and but we'll see for each well, like, here is the location, here's the depth, here's the length of the lateral, here's the configuration, which I've also changed and just summarized in A, B, or C. So as we scroll down here, you see a bunch more A, Bs, and Cs. And then the performance, I've just like normalized it all into one single number. So typically we look at decline curves, and we've got like, the gas cut versus the liquid that we care about more. All of that has been reduced into one number. And of course, if you drill a deeper well, then you have more cost. That's wrapped up in this number too. So really, this is a single score that says how profitable was the well. And you notice some wells are negative and some are positive. Here's an 11, that one's pretty good. And what machine learning is going to do for us, what the random forest is going to do for us, is predict the performance of these wells over here. So we see we've got a lakeside, a barn view, and a big slate at depth of 10 with a really short lateral length. So this is as short as I've allowed in the way that I've normalized everything. 1 on lateral length is really short. And then we've got 5, 7, and 9 for each of the 3 as well. So we're holding constant the configuration and the depth. So when I hit start, this Visual Basic macro is going to implement random forest and then use it to make a prediction here. So 2 things will happen when I hit go here. It'll create a new tab down here with a tree of the random forest. And then it'll also change all of these words and letters into numbers. So Lakeside will become a 1, Barnview will become a 2, and Big Slate will become a 3. They still are what they say they are. I've just changed them to 1, 2s, and 3s because it's easier to process when you're dealing with numbers. So when I hit start here, that'll start to happen. And while I do it, I should pull up my task manager so we can see what's happening with the computer here. So Skype is taking up a lot of memory.
I have a question while you're going through the debugging. So your values like 10, that seems like quite a short lateral. So then how did you come up with your values in your tables? Are these just for learning purposes?
How did I come up with this information?
Yeah.
This is based on, so these are based on real wells, but
okay, so
they're wells not allowed
them.
to, so I've changed them around significantly, and it's just kind of for example's sake. So you see here, there's like 1,000 or so wells in this batch, and so now we've got our predicted performance here. And so what it's telling us is that, let's see, so we're getting a 3, a 1, and a 0. So none of these look very good, but it tends to prefer location 1. And it also seems to imply that the length of the lateral doesn't matter that much, because as we move from a lateral length of 1 to 5, we're still getting a prediction of 3, 1, and 0. So what that would imply is that if you drill a longer lateral length, it costs more, and that comes out in the wash. So you get more production, but not so much more that it's worth drilling the longer lateral. So that's kind of, I don't know if I would trust this advice because this is just from one single tree, and I need to back up and explain what I mean by a tree. Typically when you build a random forest, you have several trees, and then you average the results across all of them. But I don't want to use up too much time trying to teach random forest on this call. I don't think it's the right place for that. But this is what a tree looks like. Essentially, it's a decision tree. So just really quick, whenever we have a new sample and we're trying to decide what the performance should be for that sample, we have a location, a depth, a lateral length, and a configuration. We could have more stuff. It just depends on what we want to sick our random forest on. But we have all these different features for each sample. And what a random forest will do is for each tree, it'll look through our sample and find a feature that makes a split. And so if our feature is higher than a certain amount, for this first one, it's sample 1, feature 4. If it's higher than a certain amount, then it gets put into a different branch of the tree. So we call it a random forest because it's composed of decision trees, which look like this. It's kind of a tree turned on its side. We've got a trunk here, and we've got leaves over here. And because there's a lot of them, it's a forest. I've only made one in this example. And the random word for random forest is because for each tree, we've taken a random subset of the data. So I'm kind of like getting in a little bit deeper than I should because all I really wanted to show was this part. If you want to understand more about this, you should probably take the class or someone else's class. But the main thing that you come away with here is you understand all the stuff that I just glossed over in a lot of depth, and you understand how you can tailor the tool to your specific workflow in your company. But you can use this tool to do that. So I'm going to stop sharing my screen unless, well, maybe I'll leave it open. Do you guys have any more questions about it?
Yes. Okay. So what does the display look like after you process it all? What do your results look like?
Well, so here's some results right here, but typically the results would be, I just put one tree for this just for the example, but say that you have like 10 trees. The only difference would be that rather than take the output from the first tree, which is 3, 1, and 0, and as it turned out, it did that for each of these clusters of 3 wells, it would average this 3 with what the tree number 2 gave us, and then average, across tree 3, 4, 5, however many trees we have. So it's just giving us a more accurate prediction of what the performance would be for these wells.
I mean, I know it says production data, but I don't see the one that has barrels. Sorry.
Oh, yeah. Yeah, so I just reduced all of that. Like typically we would look at a decline curve, right, and figure out about barrels. I reduced all of that just to this one performance number, just so we would have only one thing to look at in the output. Okay, so we can do a more complicated example, but it would just take longer. So I thought to just sort of show off what the tool does. You get a predicted output given inputs that you can, these are your independent variables, so you can decide for yourself where you want to drill and what depth and what lateral length, if you just want to guess what the performance is going to be. If you have a lot of data, you can put that to use, yeah.
Okay, so just to clarify, this is a clarifying moment. So basically you want to predict potential performance, which would be flow, but it's a qualitative number of like whatever at this point. But you're wanting to predict performance based on depth, lateral length, and configuration, which would be basically the frac design or something like that.
Yeah, so stages and perfs and what tools you use, yeah.
Okay, so you probably in reality would want to have more configuration columns. You would probably want to have frac design. Yes. Yeah.
Yeah, often there's like 30 some odd columns, right? Okay. And maybe I can share another version later where I add more of those in. I've reduced that for now just to show what do you get as an output when you do an input, and to just show you that it can be done in Excel, and that it didn't, I think it took 3 or 4 seconds for it to process and come out with this result. And I wanted to prove that concept because every single step of the process got output into Excel. So you can see the entire tree. If you want to troubleshoot, or if you want to get some insight into how it's making the decision, you can look back through these numbers and do that. And so anybody who learns how to use this tool doesn't have to just trust blindly that when you hit go, you get some number and you should just bank your company on it. You can really understand why it's coming up with what it is and how to tweak it so that it's as accurate as it can be in your situation.
Right.
Now, in
and
this
also
case,
you can. Okay, go ahead. Yeah, go ahead, Rick. Sorry.
No, I'm just wondering, in this case, you're using the tool kind of as a forecasting tool to figure out how a well could do or would do. But if you had the data on specific wells, then you would have an idea how they're producing and forecasting at the same time, correct?
Yeah. So I've kind of blurred the lines a little bit between regression and categorization here. Mm-hmm. So this is kind of a classification because of how I've reduced performance to a single, integer. Mm-hmm. Ordinarily, you'd have a much more complicated performance to look at. Performance, how do you mean? Do you mean, the first month's total production, or mm-hmm. do you mean the UR of the well, or, are you looking at just total barrels, or do you actually care about gas for some reason? So there's a lot of different ways to break down performance here. I've just wrapped it up into a number, so it's a 9 is better than a 1, a 0 means you broke even, and a -2 meant that you lost money from that well.
Right. This is the executive summary. This is the executive summary version. That's all they want to know.
Yeah, it's just the executive summary version. That's a good way to say it. Yeah, so you can use this, you can add as many columns here as you want, and you can add as many samples down below this one as you want. And then you hit start and it'll do the same thing. You can add more trees if you want, mm-hmm. and you can tweak how the trees are assembled.
How much data did you actually have to come up with this? Was it a lot of data or just like small?
We have a lot of data. The deal we have, this is, from other work that I do, the deal that I have with my clients is that I can't share their data, which is why I made up Lakeside and why I had to simplify, part of why I simplified everything so much. But yeah, we have a lot. I think there's 1,000 in here that it poked through in order to create this one tree that's a subset of just 20 samples. So it's a pretty small tree. Cool.
So the more trees you have, or the more forests you have, and you can have multiple forests, correct?
You can, yeah, you can have multiple forests.
Cool.
Although, yeah, having one forest per prediction, I think is typically the way people do it, and you just have lots of different trees in that forest. And the concept is that each tree is very much overfit. So the tree is I can go into, I guess, overfitting if we have time. But the tree does a really good job with predicting the accuracy of anything in the tree, but doesn't necessarily do a good job predicting accuracy, giving accurate results across the entire data set.
Mm-hmm.
But as it turns out, a lot of trees averaged together tend to give you a really good sense of what the real data overall has to say. Which is really counterintuitive, but very cool.
No, it makes sense. Yeah, I think that's pretty cool.
Yeah, ordinarily, I think probably when random forest first came out, if you asked statisticians, hey, if you take a bunch of mediocre models and you average them together, are you going to predict a high accuracy model? They would say, no way.
Right.
But as it turns out, you can do that, and it works very well. And random forest is one of the best machine learning methods out there right now.
Yeah, that's really cool.
I really like it.
I'm getting my brain around the forest, to the many forests. To I was a database analyst for a lot of years, or actually database architect. So, yeah, I go, this is kind of cool. This is really neat the way it works.
If we have more time, I can talk a little bit more about the intuition behind a tree and how we're making a split.
Yeah, we've got probably about.
That's up to you.
We can probably go about 10 more minutes.
Okay. Is that a good use of time, or should we, you guys can steer it if you have other questions about like the context or
I can geek out, so I'm going to let Susan handle this because I'll probably go way off into the weeds on this. So
okay.
So I'll look at it from potentially a geologist coming in to use it. So if I'm understanding correctly, an engineer or geologist can come in with their log data or well data, and these are not the only attributes they can incorporate. This is a flexible tool. They can put in more attributes, and they can use different numbers as well, the actual numbers, correct? Like the actual depth.
Yes, absolutely. If there's something that they want to predict about what I'm calling a sample here, one piece of data, and they want to predict something about it, they can use random forest to predict by looking through other samples that already have that dependent variable filled. So that's pretty generally useful. And then in addition, this is the classification example, if they want to take a sample and decide, is it more like these samples over here, or is it more like these other samples over there? Random forest can help them out by giving them which category it should fall into.
Well, and a lot of times, I think that this could be used for identifying underperformers or ones that maybe are good candidates for going back and evaluating if they need to be stimulated, or if there's something's going on. It's not just that that there's some way. I mean, it's hard to say in horizontal wells what exactly to do after they've declined, but it could be used for decision making and determining where to put additional laterals, right?
Yeah, for sure. So, for example, say you're looking at a specific, big source rock underground, and you want to know the maturity of it. You might have collected some other data from other source rocks and seen the results that show, wow, this is very mature, slightly mature, kind of mature, or maybe there's a specific number that you can assign about the maturity, and that can help you make a good decision about when and whether to go and explore that area. So if you have all those samples, you feed the new source rock information that you have, and this tool would look through all of the existing examples and then make a prediction as to the maturity of the new rock. So that's one example.
Yeah, and then maybe where to do increased density appropriately, or how to avoid frac interference, or determining. Could you use it basically as to have different proxies for frac interference?
Yeah, for sure. So I think there are two use cases wrapped up in that. Just generally, how much communication are you going to get between wells? So if you have examples of wells that have had communication, in their production, you can enter them in on this side, and then if you have a proposal for two wells based on their distance and what the geology is like in between them, then you can enter those in over here, and it'll give you some prediction as to what communication, and that holds true for while they're being fracked as well.
That's really useful. And that type of information, those kinds of programs are usually extremely expensive. This is really good.
Yeah, I think part of the reason why those programs are expensive is because it's hard for people to format their data to put into those programs. And that means that there's less sales, and so they have to charge more to stay in existence. That's my sense.
Right.
I think that there's a lot of opportunity for vendors like Delfin to add value when we're dealing with larger projects where there's a specific type of unstructured data that needs to be converted. Delfin really helps with that.
That makes sense, because you're not tied, and you're not tied to any specific type of data. That's the beauty of what you're doing, which is pretty darn cool. And so you could take unstructured data and find a pattern of structure in it.
Yeah, that's really what Delfin is all about. And here we can take data that's structured, but there's something that we don't know about new examples. In specific, we don't know what to predict, whether it's performance or communication or something else, or whether it needs to go in one category or another category. And then we can use our examples from the past to give us those predictions or those categories.
Now, how often do people run these kind of reports to keep up on how, let's say, a well is producing or other possibilities within what you're doing? I don't know your industry well enough to make any intelligent comment, but how often would they keep on top of this? Is it an ongoing process as data is gathered? They look at things. Is it something they would do daily, weekly, monthly?
Yeah, I think it's pretty ongoing, but there are certainly periodic times when the results matter a lot more. So thinking back to my time as a reservoir engineer, I was always looking at how our wells were doing. But once per month, I would give a big presentation to our whole team, and my analysis and my suggestions had better be pretty well informed for that one. And then once a quarter, I would give a presentation to the people who ran the whole U.S. And then there was even more at stake. So I spent a lot of time playing around with how to make more accurate predictions. The challenge, though, was just that I didn't have a tool that fit the way that I was dealing with my own data. So I would create my own spreadsheet, and I'd have my own, I'd have a column here that means something to me, and I would run calculations on this column, and then I would connect it to yet another tab in another spreadsheet, and all of my data was stored in Excel, and all of my calculations were done in Excel. I found that to be true of Delfin's clients as well. So individual workflows are very much designed by and run by the individuals, even in big firms that have a lot of standardization and protocol. So that means that a tool that's very flexible is necessary. And then how do you strike the right balance? If you make a tool that supposedly does everything for everyone, then it is going to require them to put all their data in a certain like standardized input. And on the other side, if you just try to teach everybody how to build their own tools so that they have all their own power, but you start with something like Python or SQL, that's pretty tough, I think, for people who've spent 10, 20, 30 plus years using Excel. So this is meant to be kind of a bridge. You can learn not only how to use this tool, but how to build it and how to tweak it to accomplish your specific goals in your workflow, and then gradually work from there towards what I think is going to be the new workplace in oil and gas, which will resemble a lot more workplaces that are in the software industry.
Yeah, that's cool. Do you want to come back to the screen?
Oh, sure.
So the people taking your course are going to learn quite a bit about all of this in terms of how they could use it to their benefit and how to get basic and maybe even more advanced things going, correct?
That's the goal. Yeah. It's industry specific. The examples come from the industry. The use cases for the tool, the way the tool is designed is kind of like tailored to the industry. And how far back we go in the math that underlies the machine learning and the intuition around that is also informed by experiences with people who are practitioners in the energy industry.
That's pretty neat.
That is interesting. So when you're in the actual 2-day course, you'll get to look under the hood and see actually what's firing up those algorithms, and that'll be really fun too because people can modify them.
Yeah. So in the actual 2-day course, you can see of course you'll learn quite a lot about the code that underlies the Excel spreadsheet that you guys just saw, and how to build it and what all the sub-functions are and why they exist and how to build and tweak those.
Well, what's really cool about the way you showed this, Alec, is you stimulate the imagination. Because I'm sitting here going, that's cool. And I don't know anything about what you're talking about in terms of oil and gas or anything like that, but I can picture this for a whole mess of other uses in my brain from things I've done in the past, like forward finite forecasting systems or finite forward forecasting, things like that. I'm going, this is really kind of neat. We didn't have those tools back then, or at least not available to us. And again, so you let the imagination go, and you can get some amazing results from all of this, and probably beyond what people even think that they could get.
Oh,
yeah,
sure.
I think that happens a lot. Like machine learning is one of those things that you have an iterative process that the machine undergoes, and you get an output. And if your concept as a human is that, okay, then I'm done, we listen to the machine, that's kind of naive. Like typically you're part of a greater iteration process where then you go back and you tweak your model based on the output you got. Yep. And then you run it again. And then you feel confident that your model, eventually you emerge from this iterative process feeling confident that your model is representing your data well. And then from that point, it starts to predict and classify automatically when you have new data coming in. And that's fantastic. Then you save a ton of time, you increase your production, you improve your safety. It's all the things that oil and gas wants and needs. And it's, I think, recognized more and more generally that this is going to create big step changes in impact. We're just trying to go a little bottom up here at Inly and offer it to the end users who are the individual practitioners.
Well, one thing that's really interesting now is to predict migration patterns and fluid migration and why it makes different decisions, why the gas, especially gas, why adsorption and all that. And it's like, that can be used for predicting behavior of particles in any kind of system. I mean, epidemiology, et cetera. So, I mean, these are such transferable skills.
Mm-hmm.
Yeah, it's true. I happen to know more about oil and gas than I do about epidemiology. Maybe that's well, that's definitely, I wish I had that other experience right now, just given what's happening in the world.
Yeah.
That's a tough note to end on.
Yeah.
Yeah.
All this coming from these like weird scenarios.
Yeah. Susan, you encouraged me to offer the course online as well as in person. I think that was a wise suggestion. I've shied away from that in the past because I like to walk, up and down the aisles and look at people's screens and help them troubleshoot code and that sort of thing. So I think the way it'll work with this 2-day course is if you take the class online, I'll go into a lot more detail. Because people are taking the class online, I'll go into a lot more detail about how I decided to build each of the sub-functions that, together comprise this random forest. And then if people have questions, I'll give people some time after the course individually, and we can just hop on a call like this, but not broadcasted live, of course, to talk about their use case and any challenges they're having there.
That's great.
I like that.
And we are pretty much out of time, but Alec, this is really fascinating, and I'd love to hear the feedback after the course to see what people got out of it, and what they're thinking. What kind of creative juices is this kind of stimulating in terms of, because you can see from a business perspective, if they have a much better idea how each individual well is doing, how things are going, like you said, how particles and random behavior happens. It's kind of neat. It's exciting. It really is, because again, you don't want to be working in the dark on any of this stuff. And there are patterns that you can look at that will be somewhat consistent, and they'll tell you a lot. Neat. Very nice. Thanks for sharing that with us. And this goes to more than just geologists, and it goes to everybody. So other people who are watching the show might go, that's interesting, because it will work for other industries as well.
This will, yeah.
Absolutely.
Yeah.
Yeah.
It's one of those things. I think we've identified a clear need for something like this, but it's I'm excited to see the feedback too. It's an experiment for everyone.
Yeah, cool. Well, the best of luck to you on this, and I hope it turns out great.
Thanks. All right. Well, until next time. Thanks for having me back.
Oh, our pleasure. And if you're watching the show, here's information below on how to get a hold of Alec, and we look forward to your feedback too. So we will see you next week on Life Edge. Thanks, Susan. Thanks, Alec.
Thanks. You.
Bye-bye.